Today, we are going to look at a new topic, matrices. We say matrix is what? A rectangular array of numbers in brackets. That is what matrix is. For example, let's give an example of A equal to 1, 2, 4 minus 2, 3, 7 in bracket. This is an example of a matrix. A matrix, a rectangular array of numbers in brackets. We can also have another matrix B. I can have minus 3, 1, 2, 5, and 4, 7 in brackets. This is an example of a matrix. This is matrix B. We can also have C. Let me have C as an example. 2, 0, 4. We can have 1, 2, 3, 7, 5, 1, and we have minus 2, minus 1, 3 in brackets. These are examples of matrix. What we are going to learn again is elements of matrix. What is the element of a matrix? The element of a matrix are all the numbers in the matrix, all the numbers arranged in array, in rectangular array, is referred to as the element of the matrix. So the element of the matrix, they are also referred to as the members. Now, we are going to learn another thing concerning matrix, the position of the elements. When we are moving along the horizontal, all the numbers along the horizontal, they are referred to as the row. So this is the row 1, 2, and 4. They are the first row. The second row here is minus 2, 3, and 7. Second row. In matrix C, this is the first row, the second row, the third row, and the fourth row. So we have 4 rows there. Now, the numbers along the vertical line, they are referred to as the column. They are referred to as what? The column. So, in this first one, matrix A here, we have the first column, the second column, and the third column. Our matrix B, we have what? The first column and the second column. So, it is the row and column positions that are normally used to indicate the position of an element. Now, so the position of an element is its row and column position. Let's look at example 1. Matrix A equal to 1, 2, 4, minus 2, 3, and 7. We are going to look at the elements of each of them. 1 is in the first row and the first column. So what is the position of our 1 here? Our A11 is equal to 1. A11 is equal to 1, which means the first row and the first column. Look at our 2 here. 2 is in the first row and the second column. So it is A12. So this is our 2. 4 here is what? 4 is in the first row and the third column. That is our 4. So our minus 2 is the what? Second row and first column. That is minus 2. Our A 2 2 is equal to 3. And the last one there, our number 7 here, is the second row and the third column. That is the position of the matrix. Now, the order of a matrix is the number of row and the number of column. We say that the order of a matrix is given as the number of row to the number of column. So order of matrix, we say what? This is the number of row to the number of column. And it's usually given as what? M by N. It's usually given as M by N, where M stands for the number of row and N stands for the number of column. Our order of matrix is also referred to as the dimension. So when you are told to give the dimension of a matrix, it is what? The number of each row to the number of each column. So it can simply be given as what? M times N in bracket, or it can be given as M by N. This is how we represent order of a matrix. Our M here is what? Number. Number of what? Row. And while our N is what? The number of what? The column. The number of the column. That gives us what? The order of the matrix. I'm going to talk about equal matrices. Equal matrices. What are equal matrices? We say that two or more matrices can be equal when one, their order is the same and the elements in each of the matrices in every position, they are all equal or they are the same. We say that it is what? Equal what? Matrix. We say that two or more matrices can be equal when they have the same order, their order is the same, and also the corresponding elements in each of the positions for all the matrices are also what? Equal. We refer to it as what? Equal matrix. Example, let's say we have matrix A given as what? A11, A12, A21, and A22. And we have matrix B given as -1, 4, 7, 3. -1, 4, 7, 3. Or we can simply decide to even make use of letters, different letters in this matrix by saying X, Y, N, K. I can use that. Now, if we want to look at this matrix, if we now say that A is equal to B, if we are saying that matrix A is equal to B, then it means the order of this matrix must be the same first. So what is the order of this matrix? Order of matrix A is what? The order is what? 2 by 2. Because we have what? 2 row and 2 column. 2 row and 2 column. So the order here is 2 by 2. So in order first, this matrix, they have equal order. So for this matrix A and B to be equal, then it also means that the corresponding elements in each of them, in each position, must also be equal. Hence, we can simply say that this means that our x is equal to what? -1. X is equal to -1, the corresponding element. Y is equal to y is equal to what? 4. Then our m is equal to what? 7. And our k is equal to what? 3. So we can now say that the matrices, they are what? Equal. Now next, what we are going to learn next in our matrix, we are going to talk about a square matrix. What is a square matrix? A square matrix is a matrix that have equal row and equal column. Now let's look at example of a square matrix. Let's say we have matrix D equal to 1 minus 1 3 0. This is a square matrix. This is a what? A 2 by 2 matrix. A 2 by 2 matrix. So it's a square matrix. It has equal number of row and equal number of column. We can take another example of a square matrix. Let's say we have 3 minus 2 1 4 7 6 and minus 3 0 8. This is also an example of a square matrix. What is the order? The order is what? 3 row by what? 3 what? Column. So when the row, the number of row and the number of column in a matrix is the same, we refer to it as what? As a square matrix. Now we are going to look at diagonal matrix. Diagonal matrix is a square matrix that all the elements in the main diagonal have a value, while all other elements, they are what? 0. For example, let's take an example of a matrix F, and we have 3 0 0 5. This is a diagonal matrix because all the other elements, apart from the main diagonal, the main diagonal is this diagonal from the left upwards to the right downwards. This is the main diagonal. I'm calling it the right diagonal. This diagonal have value. This is a 2 by 2 matrix. Let me take another example. If I have minus 1 0 0 0 5 0, and we have 0 0 4. This is also a diagonal matrix because all the other elements, apart from the main diagonal, all the other elements are 0, apart from the main diagonal, minus 1, 5, and 4. This is the main diagonal. So that is what we refer to as what? A diagonal what? Matrix. Now, we are going to look at identity matrix. Identity matrix. We have 2 types of identity matrix. But first, let's define what is an identity matrix. An identity matrix can be a matrix that when added to another matrix, the result will be the same as the other matrix. Also, identity matrix can also be regarded as what? A matrix that when used to multiply another matrix, it will give us the same as the other matrix in multiplication. So when an identity matrix is used to multiply another matrix, it will still result to that other matrix. This brings us to the two types of identity matrix. We have two types of identity matrix. A, we have what? Additive. We have the additive identity matrix. We have the additive identity matrix. Now, the additive identity matrix is a matrix that all its elements is equal to 0. Example, let's say we have Z is equal to 0, 0, 0, 0. This is a 2 by 2 identity matrix. Let's say we have another C is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. This is an identity matrix for addition, whereby if this matrix is added to another matrix, what will happen? The result in addition will be the same as the other matrix. Now let's say we have a matrix as D. A matrix as what? D equal to -2, 5, 4, and 3. Now, if we are not told to add Z plus D, find Z plus D, Z plus D. So if we want to look for Z plus D, this will give us what? 0, 0, 0, 0. And what do we have? Our D plus, we have what? -2, 5, 4, and 3. So if we are adding them in addition of matrix, what do we have? 0 plus -2 will give us -2. 0 plus 5 will give us what? 5. 0 plus 4 will give us 4. And 0 plus 3 will give us 3. So what do you notice? That our Z plus D is equal to the value of D. We are going to look at the second type of identity matrix. The second type of identity matrix is what? The multiplicative identity matrix. So our multiplicative identity matrix, they are usually matrices that when used to multiply another matrix, the product will be equal to that other matrix. And our multiplicative identity matrix, they are diagonal matrix that all the main diagonal is equal to 1. For example, let's give an example. I can say B equal to 1, 0, 0, 1. This is a multiplicative identity matrix. Let's look at another one. If I want to have this as G, I can have 1, 0, 0, 0, 1, 0, 0, 0, 1. This is an identity matrix. This is an identity matrix. When it is used to multiply a given value, the result will be the same as what that value. This is an identity matrix. Now let's say we are giving a value, a matrix of x equal to -2, 1, 3, 4. If we are given a value like this and we are asked to multiply to find, let's say, find x B. If we are to multiply XB, this is to multiply XB. This means that if we say XB, which is our X is minus 2, 1, 3, 4, times, we are multiplying it with what? Our B, 1, 0, 0, 1. When we multiply both of them, what becomes our value? Our value will be minus 2, 1, 3, 4. This will be the final value. In mathematics, it's just like you multiplying a value with 1. Any value 1 multiplies, it gives you that same value. 1 times 100 is equal to 100. 1 times 5 is equal to 5. 1 times minus 10 is equal to minus 10. That is similar to what the multiplicative identity matrix stands for.